This is a second part of Mrs. Ross' lecture for physical science at the Lancaster Learning Link. This is Module 9, Week 1. We're going to resume by talking about speed. If an object's position changes relative to a reference point, then the object is in motion. That's what we discussed in the last part. But how quickly that object moves in its motion, how quickly that happens, is called its speed. Speed is defined as the distance traveled divided by the time traveled. Now, what is wrong with the statement if I say our speed on the interstate was 60? 60 what? Do we mean that we traveled 60 inches in a second? Or did we travel 60 meters in a day? Or did we travel 60 miles in an hour? So once again, we see that in science and in math, units matter. We need to know what those units are. Recall the steps for problem solving that I have given you. These are especially important in this particular module. Remember that every time you do a problem for me in your on your owns, quizzes, tests, everything, you need to show 3 steps. The first step, you need to write out the equation. This doesn't have, or formula, equation or formula. I guess formula would be a better word for this. This does not have any numbers in it. It is all just telling us what quantities go together to give us the quantity we're looking for. Step number 2, that is where you put in or substitute in for each of those quantities the actual numbers that apply to them. Then step 3 is where you report your answer with the given units. So please make sure that you are showing all 3 steps of this on all of your on your owns and everything that you are doing in this module. Let's get some practice with that here. It says that a car travels 78 miles down the highway. It takes the car 1.2 hours to travel that far. At what speed is the car traveling? Now, I'd like you to do this on a piece of scratch paper. I want you to write down step 1, the formula, which is given to you right here. Step 2, plug in the numbers. And step 3, give the answer. You can pause the video while you do that. Your answer to this should be 65 miles per hour. It stated that you traveled 78 miles in 1.2 hours, and since it's distance over time is how we calculate speed, the actual answer is 65 miles per hour. Let's do another example. If the speed of the car was 65 miles per hour, which is what we just got, what is the speed of the car in meters per second? Now, this particular one is just a unit conversion. We're not calculating anything using a formula, so you do not need to use the 3 steps this time. So solve this and pause the video and resume when you have your answer. You were asked what is the speed of the car in meters per second. You calculated initially that this was 65 miles per hour. First, we're going to use the unit multiplier of 1 hour per 33,600 seconds. That allows us to cancel out the hours. Next, we're going to use the unit multiplier given to us that has meters. We're putting the meters on the top and the miles on the bottom so that the miles will cancel. If you scan through this and look, the units you have left now are meters per second. We need to multiply 65 times 1,609, then divide all of that by 3,600, and that gives us the answer of 29.1 meters per second. Now we're going to turn to the discussion of the difference between speed and velocity. What is the difference? Well, speed tells you how quickly an object moves. Velocity tells you how quickly, and it tells you in what direction the object is moving. So velocity just gives a little more information than just the speed. Let's say, for example, that you have 4 planes traveling 200 miles per hour. Well, if all you know is that they're traveling 200 miles per hour, you don't really know if they're like this, lined up and all going along at 200 miles per hour. No problem. But what if your planes were lined up like this and all going 200 miles per hour? That is going to be a big problem, and that is where we see that direction matters. It is not enough just to know that these planes were traveling at 200 miles per hour. We need to know what direction they're going. Various quantities in science have this directional information, and we define a vector quantity as a physical measurement that contains directional information. In contrast to that is what we call a scalar quantity. That is a physical measurement that does not contain directional information. So for what we're learning about in this module, we would say that speed is a scalar quantity because it tells us how fast something is going, but not in what direction. From this module, we would say that velocity is a vector quantity. It is a physical measurement. It tells us how fast, but it also needs to include what direction it's going. Now, there's kind of a handy little memory tool we can use here. For this particular module, our vector quantity starts with a V, velocity, and our scalar quantity starts with an S, speed. But don't think that that's always the case. There are lots of other vector quantities in science, and many of them do not start with a V. So, in order to understand the importance of direction, we're going to do experiment 9.1 with some eggs. So right now you need to pause this video and go to the video that I recorded of doing this experiment. So now that you've watched that other video of me doing experiment 9.1, let's review what we learned. What did we see in part 1, which was step 8, where we rolled the 2 down the ramp together? What we saw, and what you need to record in your lab report, is that as they rolled down, they were going the same speed and the same direction. Let's pick some numbers here, for example, and say that maybe they were going 0.25 meters per second. I have no idea if that's an accurate number or not, but I'm just choosing that to help us have a number to use for the relative speed. So when we calculate the relative speed of one egg relative to the other, if one egg's going 0.25 meters per second, the other egg is also going 0.25 meters per second. And since they're going in the same direction, we would subtract those to get a relative speed of 0 meters per second. What about part 2, which is step 9 of the experiment? Now, one of them sat at the bottom of the ramp while the other one came towards it. What do we see there? Is their speed now is different. One is not moving at all, the other one is moving. So their speed is different. We would also say that their direction is different because one of them is headed down the ramp and the other one isn't headed down the ramp. So their direction is different. So this time, if we were to calculate a relative speed, the one moving down the ramp, let's say it has a speed of 0.25 meters per second, but the one at the bottom of the ramp is just 0 meters per second. So their speed relative to each other is 0.25 meters per second. What about part 3, step 13? Here, they were coming together off of the different ramps. So we would say that their speed is the same. They were both going down their individual ramp at the same speed, but their direction is different. So here we would say that their relative speed, one is going 0.25 meters per second, the other is going 0.25 meters per second. But since their direction is different, we need to add those speeds together. So that would give us a relative speed of 0.5 meters per second. What we saw from this experiment is that when objects travel in the same direction, their relative speed is the difference between their individual speeds. But when objects travel in opposite directions, their relative speed is the sum of their individual speeds. This is important that you understand that. So if you need to think about that and look over this again, please do so. Let's look at example 9.2. Two cars are traveling down a road. The first car is traveling north at 55 miles per hour, and the second is a few hundred yards behind it, traveling north at 45 miles per hour. What is their relative velocity? Pause the video and figure that out. Here's what we have. We've got our first car moving at 55 miles per hour north, and the second one is behind it moving 45 miles per hour north. You were asked to calculate the relative velocity. The answer to that, here's a thorough explanation if you want to read it, but the answer to that is 10 miles per hour, but it asks for velocity, which means you have to include some direction as well. And the way we would describe the direction here is that they were traveling 10 miles per hour away from each other. That would be the direction. So this is the end of this lecture. Please make sure that you refer to the email that I sent you about what items you need to send to me and the quiz and things like that.